So, hello students. We have already started this lecture number 6 in our last class. So, today I am going to finish this lecture through this video. Okay. So, again, just quickly brush up all those concepts. We have uh, talked about characteristics of instrument, and we have seen characteristics may be broadly classified into two parts like static characteristic and dynamic characteristics, and in your syllabus only static characteristics are there, and they are further divided into again two halves. One is desirable, another is undesirable. We were talking about desirable characteristics, and we know what is called accuracy, what is called precision, and then what is the meaning of sensitivity uh, and linearity, right? So now I am going to discuss the range and span and reproducibility and repeatability. Again, two confusing terms are reproducibility and repeatability that I will explain in this video. Okay, so let me just go to that slide number 22. Yeah, so that is for range and span. Okay, so now what is range and span of an instrument? So that is the formal definition of range of an instrument. Range means, as you all know, that is the limited region where an instrument basically operates. That means, again, think a dial of an watch, or the dashboard of your car. Okay, so there are certain meters are there. Okay, speedometer for example, accelerometer for example. Okay, so in case of speedometer, in a bike especially, okay, so it indicates the current speed of the vehicle, right? Now, in that dial of the speedometer, it ranges from starting from 0 to, let's say, 200 kilometer per hour, right? So now, so this 0 to 200 kilometers, so 0 to 200, that is called specifically range of that speedometer instrument. Okay, so similarly, span means it is 200 actually. That is the difference between the upper limit and the lower limit. That means in case of earlier example, that 0 to 200 kilometer per h, what is the exact span? Span is 200. That is the number only. That means the what is the highest value minus lowest value or lower threshold value. Okay, so I hope it is clear. If it is not, then please look at this specific example. A voltmeter has 0 to 150 volt meter scale. Okay, so that is the scale. So what is its range? Its range is 0 hyphen 150. That means 0 to 150. That is the called range. And what is its span? What is its highest threshold value? Highest upper limit is 150, lower limit is 0. So that means upper limit minus lower limit, 150 minus 0, that means 150 without any unit. Okay, so that is called span. So I hope this concept of range and span is clear. To get more grip into it, please solve this question. Here it is. An instrument has a span of 100 volt. Okay, so don't this volt, you just missed out this volt because it is typo. An instrument has a span of 100, let's say. Okay, but its maximum meter reading is 50 volt. Is it possible? Yes or no? Just think about it. Well, if your answer is yes, then it will be true. Why? Because the actual range of the instrument is, it could be minus 50 to plus 50, right? Plus 50 volt. So that means its span is 100. So think about it. Okay, so the answer will be yes. And actually this range is minus 50 to plus 50, so that the span is 100-fold. So no matter, the lowest value could be negative or positive. I hope it is clear enough. Okay. Now come to these two notion. One is called repeatability of an instrument and another is called reproducibility of an instrument. These two concepts are very much similar to each other. So let me explain very carefully. Okay, so just go through this definition. It describes the closeness of the output readings when the same input is applied repeatedly over a short period of time within the same measurement conditions, measuring instrument, observer, same location, and condition of use. Okay, so that means here, what is the meaning of this repeatability? Okay, suppose I am measuring one temperature, okay, or let's say or consider our ancient example. That means we want to measure the length of a table using a scale. Okay, so now my scale is my instrument, and if my input is same, that means length of the table, which is in this case input, that is same, and my instrument is also same. If I use the same scale once again inside a same room temperature, measurement conditions means room temperature, room pressure, room humidity, all are same, constant, then we will get the same output results. If it is exactly 22.33 meter for the first time of measurement, then it will show 22.33 meter in the second reading, third reading, fourth reading, and so on. So that means it repeats itself if the input conditions are same. Okay, there is no such fluctuations in the output reading, then we call it repeatability of that particular instrument. Okay, for same input. So that means, can we say that instruments having good repeatability also have good precision? Yes, of course. This repeatability implies that good precision. Okay, fine. So now that means it will repeat the same value. So that's why it is precision is very high, very much higher. Now reproducibility, look at this definition, almost similar, but only one difference is there. It describes the closeness of the output readings for the same input again when there are, now look at this change, when there are changes in the method of measurement, conditions of measurement, measuring instrument, location, time of measurement, etc., etc. So that means, suppose I am again trying to measure the length of the table, which was 22.33 at Kolkata, let's say. Okay, now I bring that table into Darjeeling or any other state, maybe in Odisha, okay, at Bhubaneswar, and I am trying to measure the same thing again, the length actually. Okay, so now the thing is, it may change 22.33 to it may be 22.34 using the same scale or different scale or different observer too. Okay, it may constant or it may not, it may change, right? Also that 22.33 reading, if then also that instrument, okay, that instrument gives the same output, that means 22.33 meter again, then it is called reproducibility of that instrument. That means no matter the condition, no matter the location, temperature not fixed, pressure not fixed, humidity not fixed, all are fluctuating, location is not fixed, but the input is same. That means the length of that table you have to consider, right? The same table. So that same instrument, if there are changes in output for an instrument, is called reproducibility of an instrument.
So you can't change the instrument of measurement instrument, of course, from this discussion it is clear maybe. Okay, instrument you can't change. Instrument and input should be fixed, but change in environment, whole setup, if you change, but still that instrument produce the same result for the same input, then it is called reproducibility. It has a power of reproduction of same result. Whereas the repeatability means if you change the environment, then it will not repeat itself, the same value. Okay, but if it is constant, then it will repeat it like this. If I am clear, then it is very good. Okay, so now similar a comment, good reproducibility implies good accuracy. Suppose if we get an accurate instrument which is reproducible, that means we are getting good accuracy, of course, because always it will be 100 on 100, correct, like this. Okay, so this is the concept of reproducibility. For more information you can just read this book. Okay, from SK Singh, actually, Industrial Instrumentation and Control, this book. Okay, so there, or any standard information, you can go through some YouTube videos or some websites, okay, containing these two terms, reproducibility and repeatability of an instrument. Okay, so I hope it is clear. Thank you.